Okay, in this screencast we're going to look at another way of solving quadratic equations. Now in this case we're going to look at using the quadratic formula. To solve equations. Now we've been looking at loads of different techniques, and I'm sure there's a fair bit of confusion, but just hang in there, because what we're going to do, this is the last little section of the chapter, and then we're going to pull it all together, and we're going to have a look at the whole thing in review over the next few days. So let's just hang in there and just go with this. It's a formula. You just whack the things through a formula like you do with any formula, and out pops the answer. So we're going to look at how to use that in this screencast. Okay, so let's have a look at an example, and what I want to do is go back to, because this is related to solving by completing the square. In fact, it is solving by completing the square, except it's just jumping some steps and using a formula. So I'm going to say, let's have a look at an example. Solve x squared plus 4x plus 2 equals 0 by completing the square. And now in my completing the square, or solving by completing the square screencast, we solve this this exact example. So solve this by completing the square. So I'm just going to go through that. I'll do it quickly because, like I said, it's in the last screencast. What I've suggested we do is that we get rid of the 2 initially, put him on the other side. We clear a space for our completed the square, half the 4, 2, square it 4, add 4 to both sides. So we end up with x squared plus 4x plus 4 equaling 2, and then these therefore dots are important. Therefore we've created this perfect square, x plus 2 on the left, and we've got 2 on the right. We take the square root of both sides now, and as you know, that means taking the plus or minus. Remember, why do we do that? Because if x squared is 9, then x could be 3, but it could also be minus 3. Because if you square minus 3, you get 9. If you square 3, you get 9. So there's always a plus minus. There's always a positive and a negative solution. Okay, back to the task. Last thing to do is just to take this 2 and put him on the other side, making him minus 2 over there. Remember, change sides, change signs. Repeat, change sides, as I did there. Change sides, change signs to minus. Okay, there's our solution. Now, I'm now going to solve the general quadratic. Right, I'm going to solve ax squared plus bx plus c equal to 0. That's just a general quadratic equation. That fits any quadratic, fits this model. Obviously, different values of a, b, c change the style. Now, this one up here has an a value of 1, right? That little invisible number there is a 1. A b value, b is this number here in front of the x of 4, and a c value of 2. We're going to use the quadratic formula in a moment to come up with this very solution. But before we do that, I'm going to quickly show you why we use the quadratic formula. Okay, bear with me here. I'm going to work quickly, and it's going to be a little bit crazy, but hopefully you'll get the flow. Firstly, we need to get rid of this a. We need to divide every term through by a, because I can't complete a square with an ax squared. So the first thing I'm going to do is divide through by a, and that's a crazy step already. It looks very messy. Now, what do we do to complete the square? I get rid of that c on a. He goes over the other side. Over the other side you go. I put in its place half of b on a, which is b on 2a, squared, which is b squared over 4a squared. Put that on both sides. What was that? That is half of this squared becomes that. What have we got therefore on the left? We've got a perfect square. It's x plus b over 2a. Half of b over a is b over 2a. Oh, there should be a little x in there. That's that squared. Over the right hand side we've got we've got this fraction here, but if I make this, if I get a common denominator, so I multiply this by 4a, I multiply that by 4a, I end up with 4ac. I'm going to just combine this. This becomes minus 4ac. I'm just going to rewrite it in the other way. So all I've done there is I've combined these fractions and made the common denominator of 4a squared. Now, for the final move, we take the square root of both sides. So I take the square root, the plus or minus square root of b squared minus 4ac over 4a squared. And then we get x equals, taking this over the other side, becomes a negative minus b over 2a, plus or minus. Now look at this thing here. If I square root the top, and I square root the denominator individually, which is perfectly fine. Now that denominator, the square root of 4a squared is just 2a. So splitting this up becomes plus or minus b squared minus 4ac over 2a. Lo and behold, I've got common denominators. So this beautifully comes down to minus b plus or minus the square root of b squared minus 4ac all over 2a. Now that there is called the quadratic formula. All right, that's what that is, the quadratic formula. All right, that one there. So that is one of the most used formulas in mathematics. The quadratic formula. There it is. Okay. Now, right, that was crazy, wasn't it? All this, but you don't need to be able to do this. But what I don't want to just give you a formula without showing you where it comes from. You can work through this. Some of you who are really into algebra will enjoy that. All right, but we're going to use the formula now. Let's go back up to this question here. X squared plus 4x plus 2 equals 0. All right, so now we're going to solve x squared plus 4x plus 2 equals 0. All right, that's that question there, just checking that's the question. Now this time, we're not going to do the same method up here. We're not going to complete the square and all that. We're just going to use the formula. I'm just going to use the formula. So, all right, I'm going to use this formula here. Now this formula here, we just need to know, right, this value there is a, so a is equal to 1. All right, that value there is b, that's b is equal to 4. And this number here is c, that's 2. A is the coefficient of x squared, b is the coefficient of x, c is the coefficient of x to the naught, or just the constant value, the number there without any x in it. They're my values of a, b, and c. Now let's use this formula to solve it. So, solving the equation, x equals minus b, that's that right there, minus 4. Alright, so I'm going to put 4 in for b, plus or minus, here we go, square root, b squared, b is 4, so that's 16, b squared is 16, minus 4 times a, which is 1, times c, which is 2. I'll come back and work that out in a minute. 2a is 2 times a is 2. Okay, let's just figure out what this is under the square root sign. It's 16 minus 4 times 1 is 4 times 2 is 8. Obviously, we do that multiplication before we do the subtraction. All over 2. Alright, we've now got minus 4 plus or minus the square root of 8 over 2. Now, that's correct, but we can go a step further because this square root 8, we know from our work on surds that that's the square root of 4 times the square root of 2, which is 2 root 2. So we can actually write this one step better, can't we, as square root 2 root 2 over 2. And then because we're good mathematicians, we can see that 2 is a common factor of all these terms. Right, that becomes a 1, that becomes a 1. So our last line is the simplified answer, minus 2 plus or minus 1 root 2, or just root 2. Minus 2 plus or minus root 2. Alright, look at that. Same answer. Using the formula, just substituting everything in. Okay, there we go. Let's do one more example. Another example. And perhaps you can pause the video and try this for yourself. So solve 3x squared plus 6x equals minus 10. Now the question might say by using the quadratic formula, but then again it might not. In which case you solve it any way you like. It's always easier to solve using factorization, which is the method we have been using, but we can't always. The first thing we've got to do here is get this minus 10 across, isn't it? Change the side, change the sign. We can't always solve by factorization. Here we want two numbers that multiply to 30, 10 times 3, right? And add to 6. Alright, now let's come up with these little pairs of numbers. Multiply to 30, 10, 3, 31's obviously not going to work, don't know why I wrote that. 5, 6, Anything else? That's it, isn't it? I'm not getting 6 out of any of these. That means I can't factorize it. That means I have to complete the square method or use the formula. Now the formula is generally just a little bit easier to use. So if we go in and we use the formula, I know that x equals minus b plus or minus. Right, this looks like a whole pile of, doesn't it? And difficult to work to figure through. But once you get used to working with this, and you will, it's not so bad. Right, now let's just identify my A's, B's, C's. A is there, that's 3. B's there, that's 6. And C there is 10. Everything's positive, so that makes it a bit easier. Minus B, so I'd put that minus 6 straight in there. B squared, B is 6, so that's B squared is 36. Minus 4 times A, 3 times C, 10. Right, that's all over 2A, 2 times 3 is 6. Alright, so we get minus 6 plus or minus the square root of 36 minus 4 3s are twice, minus 120. That number in there is negative. Right, minus 6 plus or minus negative 36 minus 20. What's that? That's 36 minus 120, sorry. That's like minus 84. What do you think about square root of negative 4? Sorry, it's just square root of negative 84. Hopefully you understand that square root of negative 84, there is no solution to that. There's no number that squares to negative 84 because everything squares to a positive. So here we have no solution. So if we get a negative number under this square root, then we're in no solution territory. Okay, let's have a look at one more example. Righto, just one more example. I want to solve this equation here. Now, in looking to, as I suggested a moment ago, we should always look to factorize if possible. All right, so factorize if you can. All right, because it's always going to be the easiest way. So we're looking for, you should get used to just looking for two numbers here that multiply to minus 11. There's not too many numbers. 11 being prime, it's going to have to be 1 and 11. We're not going to get, we can quickly determine that we're not going to get two numbers that are going to add to 6 because 11 and 1 is never getting us 6. So that's not happening. And when that's not happening, what we tend to do then is head over and solve by using the formula. So let's do that. X equals, I'm just going to write this formula, just going to keep writing it out so that we get good at seeing it and becoming familiar with it. Righto. B, what's my B here? Might be an idea just to write down what our values of A, B, and C are. So A is equal to 1. Right, B is equal to this number here, 6. And C is equal to this number here, minus 11. Right, so we're going to take those values into my formula. So minus B is minus 6 plus or minus. Here we go. B squared is 36 minus 4 times A, which is 1, times C, which is negative 11, all over 2 times A, which is just 2. Okay, let's just tidy this thing up now. 36 minus. Now what we've got here, we're subtracting 4 times 1 is 4 times a negative 11 is negative 44. Importantly, we've got a double negative here. 36 minus a negative number over 2. 36 plus 44 is 80. So we end up with minus 6 plus or minus the square root of 80 over 2. Now we've always got to pause at this point and try and simplify this if we can, which is also excellent revision from certs. Can we simplify square root of 80? Good chance we can. I can see 4 goes into 80. Remember, we're looking for a square number that goes in to this number here. 4 goes in, but even better, I can see 16 goes into 80. 16 5s are 80. So this I'm going to, square root of 80 is actually equal to, and I'm just going to put it in the body of my answer here, 16 times 5 over 2. Alright, just keep simplifying that third. Square root of 16 is 4 root 5, and what that's going to enable me to do now is to go through and divide. Right, I've got 3 terms, so the common factor has to go into all 3. In this case it's 2. 2 is my common factor, so I've got 1 underneath, so the fraction's now gone. I've just got minus 3 plus or minus 2 root 5. Now you might remember that is a question that was done in the previous screencast. It was given to you as a solve by completing the square, and we took the 11 across and did it that way. You might still find that that's easier. I'll remind you, just a quick reminder here. Right, if you don't use the formula and you can't factorize it, you can just do what we were doing in the last exercise. Just lots of different ways of solving quadratics, because quadratics we use a lot. Alright, so what do we do? We added 9 to both sides. Right, remember this? So we had an x plus 3 on the left hand side here, and we had a 20 on the right hand side, and then we took the square root of both sides. So we got x plus 3 is equal to the square root, but remember plus or minus the square root of 20. And then we got x is equal to, we took the 3 across, became minus 3, and we took the 20, which is root 4 times root 5, which is 2 root 5. So we wrote the root 20 as 2 root 5. Minus 3 plus or minus 2 root 5. Look at that, same solution. This is using the complete the square method, and over here is using the quadratic formula. Okay, and it's going to be down to you which one you use a lot of the time, but the formula I guarantee will come in handy for you, and you'll find it beneficial to learn it. Okay, we're going to do an exercise on the quadratic formula. It's exercise 5i. You've got work requirements for that. I'll see you in class.